Welcome everybody. Thank you for tuning in. Welcome to Nature's People. Today's video is what happens in the brain of an Alzheimer's patient. I want to explain all the processes behind Alzheimer's disease and what it has to do with actually the health of an individual and the brain function and why the brain decays to an extent wherein the part of the brain called hippocampus is severely compromised. There are creation of new memories, and the retrieval of all the information inside all these brain regions is so severely compromised that the geographical antenna, or rather say, or the geographical tuning of the brain is not functioning well, and it's compromising all the subsequent functions. All right, getting right into it. So Alzheimer's disease is a disease that is very common in the elderly. Most people above 40 start having an onset of the disease, and it starts with really minor and negligible things such as, where did I keep my keys? Where did I keep my wallet? Oh, where am I? Where was I going? What is the day today? So these basic and futile questions that we're used to forgetting, they start of getting exacerbated. It's one of the symptoms of Alzheimer's. However, today I want to get into the mechanism of the disease and what it happens actually on the mechanical and the physical part of it, on what's actually probably happening inside the neurons and how we can sort of address it and have a solution to it. Getting right into it. All right, Alzheimer's disease, it's a disease of the central nervous system, but it mainly affects the hippocampus. So if I have not explained before, or you're new into these videos, hippocampus is the only and the few selected regions of the brain that seems like a chickpea. It's sort of round shape, not round in shape, it's like a jalapeno in shape. It is responsible for the creation and the retrieval of the memories. So new memories are created all the time, and they are tagged or sort of activated as far as a responsibility or I'd rather say assignment is concerned. So the more important function or a memory is the more value is going to be given in a certain part of the brain, and the more light up will be the hippocampus. So the hippocampus is responsible for creating and giving value to certain memories, and also destroying and devaluing certain memories. So what does that have to do with Alzheimer's? So one of the things that is most commonly seen in Alzheimer's patients is that this region of the brain is severely compromised. And one of the things that is also noticed in most Alzheimer's patients is that there is a buildup of a type of protein called beta amyloid plaques. All right, beta amyloid plaques. Sorry guys, I'm very brief. I'm just trying to explain each and everything in detail so that you guys can have a brief overview and can sort of take all these pieces and build them back up to have an overview of the disease and the condition, so that we can sort of have a way of addressing it and dealing with it in general. So we're talking about beta amyloid plaques. Beta amyloid plaques are very common in aging brains and brains of middle-aged men and older people brains. But beta amyloid plaques are always present in the brain at any time and any moment in our brains. Why? Because they're a protein that has recently been discovered that is, guys, you won't believe, beta amyloid plaques that are seen in the brains of Alzheimer's patients as well as Parkinson's patients. It's known as an anti-parasitic or antimicrobial agent inside the brain. How surprising is that? I mean, many people don't really know, but the beta amyloid plaques have a certain structure that tend to have a locking and puncturing effect in all sort of viruses, bacteria and all microorganisms that can be and live inside the brain environment. Remember guys, the brain is a very conservative and very sort of isolated organ inside our bodies, and it's protected by a system called the brain BBB, blood-brain barrier, which doesn't allow many things to go right in there. Only a selected few substances are able to cross past that barrier and go feed the brain cells and do whatever activities and metabolism inside there. But there's certain microbes and certain viruses and things that it really live and cross past that barrier. And the way of these beta amyloid plaques is the brain actually makes them to sort of act as antimicrobial. However, here's the thing. The build-up and the breakdown of these proteins is highly conserved and highly monitored. Now my question is, are these build-ups of beta amyloid plaques and all these other antimicrobial effects in the brain, are they going overdrive? Is it that the infection is overwhelming the immune system of the brain? Because for those of you guys who might not know, the brain has its own separate immune system. The brain's immune system, it's innate immune system. It's not adaptive. There's no novelty as far as response is concerned inside the brain and the central nervous system. So one of the things that you guys might not know is that because the brain is very conserved and very protected by this all other part of by the rest of the body, it has its own immune response. And because neurons are not supposed to die, it uses this response to sort of survive. Now, the buildup of these proteins, I want to say, sorry for being so rhetorical and so redundant. I just wanted to clarify things. So the buildup of these plaques, what they end up doing is that they interfere with the signaling and the synapses between neurons. So messages inside neurons start faltering, and they go slow, and they're not that responsive, and it's hard to retrieve memories, it's hard to create memories, it's hard to make things happen in general. So what that does is that it hampers the brain's functionality. And now the question is, how do we reduce these plaques? Well, there are many ways of reducing the plaques inside the brains. One of them is exercise. Exercise, it's really important. Go see your doctor, discuss with your doctor what would be the probable causes of the plaques. Aging is also concerned, but one of the things that is really hasn't really gotten attention and had a big shed light of is that the plaques inside the brain, surprisingly, are caused by an overdrive or a sort of latent, an infection that has been latent, and it's sort of stressing the brain's immune response. So the brain immune response, it's being overwhelmed by an external response. Imagine you are having a sinus infection, a virus, a bacteria that is able to stress the immune system of the brain. What happens is that the few particles that break down that barrier that allows things inside the brain keeps on happening in such a relentless manner that the brain doesn't really able to temper it down or to suppress it, and it ends up going into a cytokine storm. A cytokine storm means that the brain just activates the reactive part of the immune system non-stop. And then when you're having a non-stop and a non-controlled immune response inside the brain, what you'll have these beta amyloid plaques. And when you're having beta amyloid plaques, although they're antiparasitic or antimicrobial in nature, they also compromise and block the connections between neurons, and that makes neurons fire less. That makes the connection between neurons compromised, and it hampers brain function. Thank you for watching for today, guys. Stay with this video. Better videos are coming. Please stay tuned, and see you in the next one. Share, like, and subscribe. Bye for now.